Good morning, good afternoon, everybody. Jules Polonetsky at Future Privacy Forum. In theory, you know that you're on my page, but just feels obligatory to say that. But maybe you don't know as well, and I'm delighted to introduce to you two incredible members of the Future of Privacy Forum team, Brenda Leong and Sara Jordan. Dr. Sara Jordan, who is a newer member of our team, although not so new anymore, right? More than a year. We are already a year. Yeah, that's right. You know how I know how long people were here? Did you join us when we were actually in the office and haven't actually been in person? Sara was with us. Sara joined us from academia and plays an incredible role carrying forward our work on AI and machine learning research. And she's going to talk in just a little bit about a really interesting product that she and the team developed, an infographic. We love our infographics at FPF because some of the ideas that I know all of us are struggling with, until you chart it out in a way that makes sense visually, it can be hard to kind of keep it all in order. So we find the process of creating these to be an incredibly interesting learning process. So Sarah's going to talk, and we'll pull it up here on the screen. I know our team has posted it in the comments already, or is just about to, but we'll pull up and we'll walk through what we were trying to do by sort of teaching the different modes and types of AI and machine learning. But before I turn to Sara, Brenda Leong, who leads our AI and machine learning work and increasingly our work around biometrics, which is one of the really robust ways that machine learning is being used. We sometimes kind of think about these things in buckets as different privacy issues, but the reality is, whether it's facial recognition or whether it's some of the other areas, it's the advances in machine learning that are creating both the risks and the accuracy and the problems and the opportunities that are coming along and the advances in those areas. So they are perhaps the first, well, maybe not the first, but they are perhaps the tip of the spear when we think about some of these issues. So Brenda has launched a really intriguing project that is tied to AI and machine learning. So many of the debates and the publicity kind of getting attention, getting things around AI and machine learning have been around things like race, the color of your skin, and how machine learning and facial recognition can get it so wrong with harmful consequences. We talk about bias. We talk about all the issues that a lot of the people in our community here, I think, are quite worried about. In general, we worried about machine learning being inclusive, right? Inclusive so that it actually captures the full population and that we can understand different effects, and are we leaving people out? We don't seem to be talking a lot about older people. And obviously, in many ways, that's an audience that is going to both be worried about machine learning and in some ways potentially going to benefit. In many societies, we don't have caregivers adequate as the population is rapidly aging. Many people pay attention to what's happening in Japan, where there's a significant elderly population and far fewer availability of a younger generation to care and support. And in many ways, you see scientists in that country in the lead and looking for sort of machine learning tools and robots and the like. But Brenda, let me kick over to you to talk about this new project that we are doing together with AARP for our global audience, the American Association of Retired Persons, one of the largest associations in the world, representing many millions of adults, and their interest, of course, in understanding what the technology here means, risks, and perhaps places where we need more people engaged. So, Brenda, the floor to you, and tell us a bit more about what is going on and how people can even get involved.
Thanks, Jules. Very much appreciate it. As Jules pointed out, we're interested in inclusivity. We're interested in intersectionality of all of the buckets people might get put into as users of the internet and digital services. And AARP came to us several months ago and said, our cohort is older adults, people over 50, which of course is a huge age range of a variety of groups already. And we want to understand, are they being sufficiently represented as we transition to more and more machine learning based systems? We read and hear about representation of various groups underrepresented in training data sets, in test cases, test uses. And so as a group of consumers that are both part of the general market, that is products and services that are just targeted broadly to adults, people, users generally, and also as a particular demographic that is going to receive marketing for products and services theoretically aimed specifically to them, are people in this group being sufficiently included in the design, development, testing, and implementation of AI and machine learning based systems. So we said, okay, we'd love to look into that. And we are now midway through a long project to assess the answer to that question, which is, of course, not simple or easy. So we started out by doing a literature review to sort of assess the state of the state on where things stand now in terms of the research that is representative of the needs and specific requirements of different cohorts within the older adult community, what that might look like and how those are being represented. There is a lot of research going on in that area, and we broke it down into a number of areas, work and retirement activities, sort of daily activity things, including just, digital access generally. Older people tend to live more likely in a rural environment as a percentage than urban in many cases. So are there access issues? We looked at banking, online shopping, travel planning, and other sort of general services that we operate in our day-to-day lives. We also looked at things that are home and community based. So connected devices in your home, security systems, all of the IoT connected platforms that we use from home or from our device on a daily basis. And even things like online dating or real estate or other components of transitional moments in life where people are engaging in these needs as well. We certainly looked at security. What are the security issues, both physical and cybersecurity for folks? And then, of course, there's a big section where we looked at health issues and healthcare, and both in-home care, medical services, again, access and availability, things about wearables and devices that are tracking our physiological data that we adopt on our own without necessarily being through any kind of provider. And even things like AR and VR systems, augmented reality and virtual reality programs and systems that are being used more and more in therapy programs, as well as in entertainment and just general quality of life aspects. And finally, we looked at social media and the digital environment generally, to the extent are people in these cohorts engaged, what is their satisfaction level, what are some of the issues they might experience in using these services, and what research is being done there to answer their particular requirements. So having more or less wrapped up that first stage, we're now getting ready to hold an event where we call in many of the researchers whose work we looked at and cited, as well as others in the field who have been doing a lot of work here, as well as others who are not necessarily academic researchers, but who have broad experience either in perhaps healthcare or physical activity, sports and leisure support, as well as online data applications and programs targeted to the older adult population education sources. And we broke that into basically two groups for an event that we're going to hold. Two panels. The first one is going to be sort of more of the social impacts, the legal and policy issues around older adult specific technology. And then the second one is going to be more focused on the technology aspects itself, the technical issues and concerns of designing these programs and models, building these machine learning algorithms, and testing them and training them and then using them. So we are holding this event March 18th. The registration link is on the screen. Anyone is welcome to sign up and attend. We would love to have you there as we listen to these experts engage on these topics. And then following that, we will be doing the third stage of this project, which my colleague, Sara Jordan, who you're going to hear from in a minute, will be carrying out, which is to do an actual research study evaluating somewhere between 100 and 200 of the most commonly used commercial data sets for developing machine learning systems to evaluate them for representation of the older adult community. So in other words, if you're a startup, you have an idea for an app or a program or a system, and you're going to use a machine learning model on which to base it, and you're going to go out and commercially obtain data sets to train that model. Are those data sets sufficiently representative of these cohorts, and not just 50 and above, but by the sub tracks within that as well, like 50 to 60, 60 to 70, because obviously you can imagine that 50 to 60-year-olds have probably a much different behavior pattern and needs focused digital life than maybe the 80 and above cohort, which is going to behave very differently. So with that, I will turn it over to Sara to either wrap that up or also move on to our infographic.
Let me just give a quick shout out. Thank you, Brenda. Great summary there. And a quick shout out to our friends, some of us in the comments here. Dominique Shelton Leipzig. Hi, Dominique. Dominique's out in LA and has played such a big role in raising some of the issues around law and discrimination and so forth. And, you think, how could we be forgetting, about including, big chunks of society? How is that possible? But yet somehow we do, right? Historically, we've done it maybe intentionally, given the way we've treated race and other classes of people. But how could we? Well, we seem to forget women often, and well, there's a lot of them around. We had a phenomenal book event with a fabulous author who just demonstrated that, on major diseases, like somehow we don't consider women. For years, I'm wondering how people buy phones if their hands are not the size of some of these, giant phones, and women, it may have smaller hands than men. So I guess we shouldn't be shocked, especially now. And again, if you're in the US, what you're doing now for some of our global audience, what you're doing now, if you're a senior, is you're chasing vaccine appointments by going to 50 different websites and clicking, and more adept people are volunteering and forming sort of teams to help older adults sign up for the vaccine when they are primarily the ones that are eligible. They are the first cohort that is eligible for the vaccine. In many places in the US, it was 75 and up. So how did we launch this? Did we say, I don't know, how do people 75 and up make an appointment to go to the doctor? No, we said, let's create hundreds of websites, send them out by email and text, distribute them in ways that you have to quickly jump and vastly fill in, right? And so forget about sophisticated stuff like machine learning, like the most basic thing in society, rescuing ourselves from the vaccine, aimed at the older adult audience that has been the most at risk. And we just somehow created a system that completely doesn't work for that audience. So, I mean, head exploding, obviously, when it comes to can we do better when it comes to what we're going to be building when it comes to AI and machine learning. Sara, over to you, because this is what you think about all the time.
Yeah, so Jules, that's a great point. How in the world do we improve user experience and user design for older persons? Well, if you're doing that in machine learning, you're trapped in some cases by the data that you have, or you're going to have the very expensive process of going out and getting that data. And every time you interact with someone to gather data from them, you introduce some risks for exposure of that person when you're asking them to give you more information. So how in the world do we figure out how good the ecosystem of benchmark data sets is for older people? Well, that's the third phase of our research project here with AARP. So for those of you out here in the LinkedIn universe, if you have what you think is a truly representative data set and think that you already have solved this problem, I'd love to hear from you, and to represent and figure out what you're doing and how you've done it well, and assess, how well have you bucketized some of the older adults' concerns, their facial images, objects for older adults, housing data. Show me where people have been writing movie reviews that are 75 years old, so we can figure out how to insert them into that wonderful IMDb type of data set. So really the whole point of the AARP project is to ask about the data, but data has to be cooked. It has to be reformed through the process of machine learning and through artificial intelligence, which brings us to that infographic project. And our infographic it serves a lot of different functions. And I hope that these functions help those of you out there, here in the LinkedIn universe this morning. And really one of the first ones is to ensure that there is adequate education for those people who have an interest in regulating AI. So we're concerned about things such as equity for older persons, for people of different racial groups, for gender communities. We want to make sure that this is something that serves everyone. And sometimes in the case where we want to improve the equity of the application, we may want to overreach and say, let's regulate all AI or let's regulate all machine learning. Well, one of the things that this infographic strives to do is to say, that's a really big spectrum. That's a super big landscape where we probably need to think about what are the areas where there is a higher level of risk associated with the use of the particular machine learning or particular artificial intelligence that introduces the chance for discrimination, for disparity, for harm. And that was one of the first things that led us to start to think about, well, how do we tell people how to intelligently regulate AI? But it's also a side where we want to interact with the people on the developer community and people on the technical side to learn more about what it is that they are doing. And for those of you who are constantly surfing archive, meta-archive, bioarchive, et cetera, to look at what computer scientists are doing and computer scientists in concert with other disciplinary experts, you'll know that there are so many different ways in which we are developing new machine learning algorithms, new forms of AI, and it can be hard to keep up. So if you're trying to keep up with that, sometimes it's useful to have a little bit better of a sense of where some of those new innovations fit in the bigger buckets of, parts of machine learning or parts of artificial intelligence. So there's really two educational valences for this. There's also, people want to know, how does AI actually power the things that we use? How does it actually help us to do things like fill out our taxes? How does it help us to deal with some of the knottier issues in society, such as speech and content moderation? So in this infographic, we have not only the landscape of artificial intelligence, the spectrum of it, but also a couple of use cases you'll see in that L shape on the side here. So to walk you through this infographic, one of the easiest ways to read this is that there are two general ways of thinking about AI. And one of them is sort of symbolic or rules-based AI. And that's what's represented over here on the left-hand side, of at least my screen, right? In orange shades and pink. And then over here on the green side, the connectionist or machine learning side, you'll find things like neural networks, deep networks, adversarial learning, etc. And it's important that we understand the differences here because the risks and the explanation burden for symbolic or rules-based AI is really qualitatively different than that which is arises from connectionist type of AI. So if you look at this particular infographic and look at the orange side, those things that represent planning and scheduling, search, symbolic AI generally understood, expert systems, most of these are able to be programmed by a set of very complicated, not saying it's not complicated, but complicated rules that we could, in theory, given infinite time and chalk, right, explain. We could say how it is that a machine comes to a particular output that we can use as a decision in order to be able to advance whatever objectives we have. So for example, if you're talking about planning and scheduling and you like looking at the Hubble telescope images that you can find on the internet, well, you can kind of thank planning and scheduling algorithms because we got to figure out where to point that telescope at any given point, and planning and scheduling algorithms help us with that. But on the ground, even when we talk about things like how groceries are delivered and ensuring logistics works well, planning and scheduling helps with that. It also helps with us dealing with robotics, right? If we want to get our packages from one place to another and we want to reduce the probability of warehouse workers being injured, we can use some forms of robotics to be able to pick up packages, move packages, conveyance, etc. And robotics can help us there. Robots can be programmed through symbolic or rules-based sort of AI that can also be programmed and assisted through other things like computer sensing, computer vision, and forms of machine learning, right? So you can also think of other very quotidian things that we like to enjoy in our daily lives, like expert systems. When you go to a physician, when you go to someone who is a qualified expert in a number of different domains, they may use an expert system to help them to knit together the huge amount of knowledge that they need to have on hand readily available to be able to serve you an answer that helps you to make yourself well, to choose the right drug, to choose the right procedure. So when we talk about regulating AI, we talk about symbolic types of AI, we're talking about something that is often very close to what makes our lives convenient, and in some cases makes our lives better. Machine learning also helps us to make our lives super interesting and exciting, and oftentimes more sort of effervescent, more sparkly. So for one of the things that you can think of machine learning helping us to do is things like even just Snapchat filters, right? And helping us to augment our images, to augment our daily lives. It can be something that helps us to mine through the vast amount of literature faster. The combination of, say, natural language processing, natural language understanding, and forms of machine learning help us to synthesize that huge and growing batch of expert articles out there, whether or not in preprint archives or in journals. So those things that help us to learn more about our world. And those things that also help us to look towards the future of machine learning and of more capable and interactive robots. So learning, for example, how to have a robotic system navigate the complicated streets and sidewalks of many of our cities. We need to be able to train them using things like computer vision and things like reinforcement learning in a state space or in a space where we don't know all of the different components that are going to come up, whether or not it's going to be a loose cobblestone or a loose poodle, right? Those things, how to navigate that space, we can teach that through things like reinforcement learning. But to go back to the original educative purpose of this infographic, really what we're trying to do is to show that, well, AI is a spectrum, right? And when we collapse things into saying that all machine learning or all artificial intelligence is just AI, right? Or it is all one thing, that's really sort of reductionist. And in the drive to reduce things to something that is easy to say, we may lose some of the nuance of things that make our lives better. Not to say that there's not risks associated with AI. In the white paper that's associated with this particular infographic, we do highlight a number of those risks. And we want to make sure that we take into account those things that are super risky and those things that are perhaps less risky. But to be able to pin risk to things, we need to know something about the data, right? We need to know something about who's represented in that data, back to the AARP project, but also we need to know something about how this data is cooked, right? And how it's transformed through machine learning.
Sarah, let me ask you this. One thing that has been getting me a bit troubled, maybe amused. The other day, there was a headline story that said, the algorithm that is assigning where vaccines are distributed has all these problems, and AI is now messing up our vaccine distribution. And there was a critique of that because people sat down, they came up with some ethical models, give the seniors first, give the people with frontline jobs here and this and that. And those rules were then, put into a computer program that when you typed in XYZ, it said, okay, therefore send this number of vaccines to this place. And there was no machine learning. There was no, quote unquote, the algorithm is determining it. We did what we do, which is we put our decisions in code, and sometimes they make no sense because they were complicated or whatever the case was. And this has been a problem with data and privacy and technology and computing for a super long time. And yes, we need to be yelling and thinking and talking about the data and the bias and so forth. But half of the conversations that we seem to be having around machine learning and AI are the ones I had 20 years ago when I didn't even know what machine learning meant, as a junior person playing a privacy officer role where people said, oh my God, you've got a lot of data, bad things will happen. I think there's value. And look, if sexy labels and new terms like are the reason we look at old problems, awesome. But I think what we are particularly interested in doing is saying, wait a second, there are some new things happening here because of unsupervised learning, because of technology that, seems to be trusted as human-like in the way it interacts, right? There's a host of unresolved, unique, or enhanced troublesome issues. So how do you think about sort of that? And is it important? Does it really matter to parse that out? It seems like it does, because that's where, some of the unique challenges that have to be grappled with are solved.
Jules, I think I would probably one-up your history to say that it's longer than 20 years, right? And these are the problems we've been dealing with for forever, right? These are just problems of optimization, right? And your example of vaccination algorithms, this is a constrained optimization problem. And the engineers that have been trying to solve these issues for centuries now, right, would look at this and go, we are still back in square one, aren't we? And that's frustrating because you do feel like you just repeat yourself and you do it under the guise of new labels. I'm perfectly sympathetic with what you're saying, but I wonder whether or not when we look at some of these things like unsupervised learning or semi-supervised learning or self-supervised learning, and there's a new label for this stuff every day, it seems, right? One of the things we're talking about is, darn it, how do we make better decisions? We could roll back, 10 years, we're talking about big data powering decisions. And then we can roll back 10 years before that, and we're talking about data-driven policymaking or data-informed or expert-informed policymaking. We're still just struggling with how do we make better decisions under the many constraints that we have. And as you pointed out, sometimes when you set these rules out and you start to think how they knit together, it just shows some of the inherent contradictions that we as humans navigate easily. And when we give them to somebody else, we give that cookbook to someone else, it's very difficult for them to follow. It's just that frustrating problem like when you're a new cook and someone says, use a dash of cloves. And if you're new and you put a teaspoon as a dash of cloves, you're going to be super disappointed with that recipe by the end of it, right? Because it's just going to overpower the system. And this is the same with machine learning. Sometimes when we put out the rules and we don't necessarily know what we're doing, or we cook it in just a slightly different way, we get things that we just couldn't have anticipated. We don't get the flavor that we were looking for. Dealing with decisions, we're just still at that square one. How do we optimize under these constraints?
I love the cooking recipe as someone who's a kind of fumbles around the kitchen. But like many of us, trying to do a little bit more of that at home. I realized recently I didn't know the difference between a lobe of garlic and like the entire clove. Like, how much is the clove? Is a clove just like one little? I never had to confront that before. So. One thing I'm super excited about for our listeners here is that, until relatively recently, us privacy people on the compliance and legal side, we're a bunch of lawyers, and we talk about a lot of things and, hopefully provide some useful thinking. But it's been great with Sara and a couple of other people coming from the research community who've joined us recently to actually start having the capacity to actually do research on our own, not just legal research, but actually working with data. Really, really exciting and a big maturity point for our capacity. So you all have work to do, and we all have work to do. So thanks for a quick snap catch up here with us. We're going to try to do this every Friday with different staff or different guests. So if you want to join me, give a ping. We'll catch up. We didn't have time to engage with a lot of the comments. We'll try to catch up a little bit during the day, thanks to a number of friends here that I see joining us. The infographic, I always get emails from people saying, can I use your infographic? I loved it on smart cities, on this, on that, in our presentation. Stop asking. The answer is yes. Our website says all the public comment here is Creative Commons licensed. with attribution, please, but our logo is on there, so that's fine. Please take it, use it, print out a big poster for your office wall. I'm so excited when I travel around the world and visit different organizations or companies or universities, and I see one of our infographics printed out big and on a wall. It just makes my day. So please take our stuff, and we welcome you using it as one of our contributions, hopefully useful to the community. Brenda, thanks so much for joining me. If you're interested, please do join us at the event with AARP to give your input and opinion. And Sara, thank you so much. Hey, everybody, have a great day. Have a good weekend.